what's happening here? This train is going further away north. This train is traveling east, and it's traveling west. But as I push play, this graph is the derivative I'm looking for, distance as a function of time. Now, remember, distance as a function of time is going to be what? That's going to be our derivative. D dt, which we're going to find, or dd dt, however we want to label it. We're going to do that in a second. But so as I play this, this is what's happening. The trains are getting closer and closer, and then finally the trains just keep getting further away. So this is that piece of what's happening that gives us a graph of how far at any moment the trains are away from each other. All right, so after the initial shock is over of our train question that everyone, like I said, I have to do this because it always is the one all the comedians go ahead and make jokes about. What is given to us? What do we know? And what do we need to find? Now, for this given portion, and I stopped it here for a reason. Do you think it would be very, very helpful for us to go ahead and find and draw a picture of what this looks like? Yeah. And what is the closest geometric shape that we have? Triangle. Yep. We can't say it's 45 degrees because the train changes, right? The size of the triangle changes. But even if it kept going, as soon as it moves over to the other side, I still have a triangle. So I'm going to go ahead and make this triangle. I'm going to make and label this X, Y, and Z. You can label them anything you want. So at the start of this, what do we know? Magnus, the parabola is the distance function over time, where the trains are what we're looking at. So at the static moment in the very, very beginning, if I go back to t is equal to 0, what do I know? What is x? X is equal to 20 when the time is equal to 0, right? Now, do we know dy dx, or excuse me, dy dt? And what does that mean? That means, do I know the rate of change of y? What is the rate of change? The rate of change would be of y would be this train here, correct? Yes, we do. We know dy dt is equal to 1.5 minutes per mile. And Adrian, you are also right. I know that y is equal to 10 when t is equal to 0. What else do I know? Julie, I know it's because it tells me. You see one train traveling towards Denver. Oops, that's not the right one. One train travels north away from Denver at 1.5 minutes per mile. And since it's traveling north, that's the train that is traveling up. Miles per Thank you, Magnus. It is 1.5 minutes per mile.